Hello, my name is Josiah Smith, and today I will be helping us learn about halogenation of an aromatic. So jumping right to it, right here we have our initial benzene ring, and we can see that just through the addition of the bromine molecule, just in its diatomic form, we do not get any intended product. But when we add it with iron and iron bromide, so an iron molecule with 3 bromines attached to it, it actually can add a bromine, and we'll talk about why here in a minute using the mechanism. But the major functions for this whole reaction is the formation of a good leaving group for the elimination or later substitution. So what this means is that the bromine is a far better leaving group and can be easily replaced with another molecule. Now, there's another function that this has, and that is the formation of a Grignard reagent. So the Grignard reagent would be, for example, adding magnesium and therefore making the carbon here, it would make the bromine basically leave, and the carbon here would actually be negative, allowing it to attack very many different species of molecules. Now, the mechanism really isn't as hard as it may seem. All we do is we take our diatomic bromine, and one of them is going to attack the iron. And that's a coordination step for our first step. So the electrons here attack the iron, and it creates this molecule. So the iron is negatively charged, and this bromine is positively charged. So one way that really just occurs is that this bond will break, and the electrons will go to that bromine. And that one will become more stable, and this bromine will now be positive. And this was our intended bromine product. So that was a heterolysis step. So then what we do is we now have the benzene ring, and its double bond is going to reach out and is going to attach to the positive bromine. So now we have, through this electrophilic addition, we have 3 different resonance forms to which the positive charge can move. So we have the first positive charge on this carbon, which would be where the double bond broke here, as you can see. And then you can see as the arrow shows which bond is switching where to move the positive charge, which makes the carbocation here way more stable than it would be if there was no resonance. So we take one of our products, and now we go back to the iron atom, and we say, well, we could regenerate our beginning iron molecule, and then we'll actually have HBr for a product as well, because the bromine will grab onto the hydrogen, and that hydrogen bond will break off and form a double bond in the benzene ring, completing it and leaving the bromine on. So that's an electrophile elimination step, and these 3 are your products. For the last minute, I just wanted to have a few notes on other halogens. So iodine can be added to an aromatic ring in the presence of an oxidizer. So I2 becomes an I+ in the mechanism. So recently there is a lab in this semester where we add bleach to iodine. So iodine becomes positively charged, and the carbon on the benzene ring attacks it. So you can see that here with CuCl2. Fluorine reacts the same as the iodine, so that also needs an oxidizer in order to be added. And then chlorine is actually the same as bromine, so that needs that chloride and iron chloride molecule.